Welcome to the Geological Oscars, and it's my pleasure for the final time as President to remind you of the Lewis Carroll escape route. Behind this curtain is a passageway which will only the most nimble amongst you will make it through there. And you will emerge in the midst of a building site that's masquerading as the latest piece of architecture exhibit in front of the Royal Academy. So you can nod at Joshua Reynolds, and then the muster point is Walker's Pub just at the back of Fortnum and Mason. Have I got that right finally, Edmund? My pleasure to begin the awards ceremony with the Neil Duncan Award, which is a bursary given to a student at Portsmouth University by this society. Neil Duncan is a senior fellow of this society who was responsible for starting the Engineering, Geology and Geotechnics course at Portsmouth in 1967. Neil was hoping to be here, but alas, he can't be with us. He's not well. We send our very best wishes to him. And it's in honour of the achievement of establishing that course that the department makes this award, which this year goes to Liam Flood. Liam says in his still necessarily rather brief CV that he's, quote, looking forward to getting the most out of the degree course and industrial placement and gaining a better understanding of the way ground engineering is used in industry. Please welcome Mr. Liam Flood. Well done. Now, anybody who's ever been president of anything will know that they keep you on a short leash most of the time, and there isn't much they let you do without a minder, or in my case, a whole room full of them up the stairs there. And they sit around the council table, and boy, they're quite an intimidating bunch. But there's a couple of areas where I'm let out on my own, and one of them you're going to suffer unless you nip off to the pub before. At the end of the afternoon, I'm going to talk about my research. And the other thing I'm allowed to do on my own without too much interference is make a couple of President's Awards. Now, these awards were instigated under the presidency of the late, great Perce Allen, who, to my generation of sedimentologists, is right up there with Hal Redding and others as just the most wonderful, inspirational character who helped found a whole new discipline in our subject, and also taught us all to have a lot of fun doing it. So these two awards, I don't have to take anybody else's advice, but be reassured that I do actually seek advice from people who can recognize rare promise when they see it. The final choices are mine, which is why they're called the President's Awards. And the first one goes to an exceptionally gifted young French geologist working in the UK, Romain Guilbault. Romain graduated from Grenoble in 2005, completed an MSc there, which included a year in Freiburg im Breisgau in Germany. He moved to Edinburgh for a PhD in experimental geochemistry, held visiting positions at Cardiff and Jerusalem, and he's now a postdoc at Newcastle. Romain has been the lead author on papers in the Journal of Analytical Atomic Spectrometry, Geochimica and Cosmochimica Acta, Science and Earth and Planetary Science Letters, and he's still only 27. Some of us here would like to have that kind of list at a more advanced age. Romain is also remarkable for his breadth of expertise. He's currently focusing on the co-evolution of life and the planet in the Neo-Proterozoic, the evolving redox state of the ocean, and links to nutrient availability and oxygen production. He has to me, that vital quality of combining work in the laboratory and in the field to break important new ground. Romain Guilbault, you have an unusually broad range of skills for one still at an early stage in your career, and this is reflected in this already fine record of publication. It's quite a beginning, and it's my pleasure today to give you the first President's Award. The second President's Award today goes to Karis Bennett, who, in admirable symmetry with Romain, is currently studying at the University of Lille in France. Karis graduated from Liverpool, earning the accolade as easily among the top 5% of Liverpool graduates, which is some praise considering the competition in that cohort. Her doctoral work reflected the breadth of interest noted by her teachers, as she went to Leicester University on a NERC case studentship to study carboniferous ostracods and isotopes. Her project principally concerned identifying the first colonization by ostracods of non-marine environments from marine and brackish water dwelling ancestors. This is difficult and controversial work and required a multidisciplinary approach, drawing in micropaleontology, palynology, sedimentology, and isotope research. After a spell as research associate at Leicester University, she's now postdoctoral fellow at Lille, where she's developing a proxy for Ordovician seawater temperature using the eyes of pelagic trilobites. Karis Bennett, you're a careful and meticulous scientist of great promise, and it's my pleasure to confer this award upon you today. We come now to the Society's Distinguished Service Awards. Ian Jackson has had an outstanding career spanning some 37 years with BGS, worth a medal in its own right there. The last 15 of which have witnessed his truly remarkable contribution in the field of geoscience information, both at home and internationally. Ian was in the vanguard of those who recognized the potential offered to organizations such as BGS by advances in computing. A strong theme in his career is the exploitation of geoscience data to make positive and lasting socio-economic impacts. As BGS's Director of Information, Ian's achievements include developing and publishing the world's first national digital geological map database at 1 to 50,000. Together with the first national digital geohazard dataset at the same scale. He instigated and delivered the first atlas of digital geoenvironmental information for the UK, Britain Beneath Our Feet. He steered the development of the BGS website, which led to worldwide recognition of BGS as a leader in geoscience information management and delivery. He successfully completed innovative projects to create 3D geological modeling, digital field mapping and visualization capability, now deployed right across BGS and emulated by many other surveys. Not surprisingly, Ian is in demand internationally as advisor on geoscience information strategies. Ian was the architect and still is the coordinator of the principal UK scientific contribution to the UN International Year of Planet Earth, namely the One Geology Project, which uses geoinformatics and interoperable data standards to deliver geological map data from 117 nations via the web. The success of this project and its outreach program has raised geoscience awareness on a truly global scale and brought geological surveys from across the world together to a remarkable degree. I have had the pleasure of working with Ian on matters connected with recruitment of young staff into BGS and can attest to his determination that our profession should ensure that its priority is always to serve society and not itself. Ian Jackson, for your pioneering and indefatigable work on bringing the geological world into the age of delivery of digital information, we're delighted to award you the Distinguished Service Award of the Geological Society of London. This year we make 2 Distinguished Service Awards, and the second goes to an intrepid journalist, writer and traveller who studied geology because above all he wanted to see the world, and his partial colour blindness had ruled him out of a career in Her Majesty's Navy. Simon, I'm astonished you managed to get a degree out of Oxford University in those days, because it was largely awarded on the ability to distinguish different minerals in basic igneous rocks under the petrographic microscope.
I'll explain later.
Yeah, thank you. The senior service's loss was the gain of his worldwide readership, and not least of this society. Simon Winchester, OBE, has promoted widespread recognition of the man whose eyes burn into us from his portrait as we enter Burlington House to study his map, William Smith. Simon has reported from all over the world, most notably for The Guardian, The Sunday Times, and later Harper's, The Atlantic, Smithsonian Magazine, and National Geographic. However, since the spectacular success of his first bestseller, The Surgeon of Crowthorne, he's devoted his time to writing books, many of which draw upon the geology he learnt as a mining geologist in Uganda and at Oxford University. From his time as undergraduate at Oxford, Simon acknowledges a particular debt to Harold Redding in his Map That Changed the World. This book is another New York Times bestseller, which brought geology to the attention of a large audience of general readers, the stuff of dreams for writers of popular science. It's fair to say that he's made keen amateurs of geologists of those who might previously never have shown any interest at all in earth science. Subsequent books have included several with broadly geological themes, including A Crack in the Edge of the World, Krakatoa, and more recently Atlantic. Since 2001, Simon has worked with geological bodies worldwide, notably GSA, USGS, SEPM, and BGS, as presenter, speaker, and lecturer, appearing at the One Geology presentation at the Oslo IGC was one example. He was also Goodwill Ambassador for the UN International Year of Planet Earth. Simon Winchester, we hope that you will continue to bring our science to the attention of your readers, and that you will accept with our deep gratitude the Distinguished Service Award of the Geological Society of London. We now come to the funds awarded by this society. The Murchison Fund of the Society is awarded to Dr. Russell Wynne of the National Oceanography Centre, Southampton, where he leads a group of some 40 staff and PhD students as head of marine geoscience. His research concentrates on sedimentary processes in deep sea systems and has had a significant impact in both pure and applied geoscience. His work has characterized and interpreted the deep water scours and bed forms generated by turbidity and bottom currents, and synthesized sedimentological processes and products in deep water sinuous channels and channel lobe transition zones. He's analyzed the timing, trigger, mechanisms and character of volcanic island landslides using distal turbidites to demonstrate multi-stage failure of source landslides in the Canary Islands. Russell, I want to hear a bit more about that, but maybe not immediately. His work thus has implications for both geohazards and hydrocarbon exploration. In 2008, he won the BSRG Award for Research by Scientists Under 40, named for the late Roland Goldring. Russell's research, documented in over 60 papers, has received financial support from both research councils and industry. His wide-ranging curiosity has enabled him to turn his biological interests into a second career, studying the distribution and ecology of seabirds and cetaceans. Russell Wynne, we are pleased to award you the Murchison Fund of the Geological Society of London. The Lyell Fund of the Society is awarded this year to Daniela Schmidt of the University of Bristol. Danny won the silver medal for the best PhD in Earth Sciences at ETH in Zurich in 2003 and has continued to garner honours ever since, including a NERC postdoctoral fellowship, the Micropaleontological Society's Downey Award and the W. Storrs Cole Award of the GSA. In 2006, she won a Royal Society University Research Fellowship. Danny has made significant and substantial contributions to our understanding of micropaleontology and its application to climate change during the past 100 million years. A key finding was that planktic forams increased in size through the Cenozoic as an adaptive response to intensifying surface water stratification in low latitudes, driven by polar cooling. She's since diversified her research, working with isotope geochemists and climate modelers on assessing the effect of ocean acidification and warming on future ecosystems. Danny Schmidt is a gregarious scientist who enters fully into the wider life of science while extending micropaleontology teaching at undergraduate and master's level at a time when the discipline is under pressure elsewhere. Daniela unfortunately cannot be with us today, but she tells me she is delighted to accept the award, which we will ensure reaches her safely. So let's give her a clap in her absence. We will record Steph that there was hearty applause at this point. We'll send that to her. The William Smith Fund this year goes to a strongly multidisciplinary researcher who focuses on the application of spatial data analysis, visualization, and near-surface geophysical techniques to a broad range of geological, engineering, environmental, and archaeological problems. He is Dr. Jamie Pringle of the University of Kiel. The cross-disciplinary application of Jamie's research means that he has an impact on a wide range of communities. For example, his work on applying shallow geophysical prospecting techniques is capable not only of detecting buried archaeological features, but also clandestine graves, impacting significantly on the emerging science of forensic geophysics. Jamie serves as a committee member of the Society's Forensic Geology and Near-Surface Geophysics groups. The quantitative data sets that result from his spatial data analysis and visualization techniques allow the construction and interrogation of virtual models of geological outcrops. These models have been used to constrain sedimentological architecture in petroleum reservoir analogues and thus to inform flow modeling studies. Jamie Pringle, your research not only serves many constituencies within our science, but underpins and enriches the education and training of near-surface geophysicists. Please accept the William Smith Fund of the Geological Society of London. At a time when fears are being expressed about the future of micropaleontology in the UK, it's a great pleasure to present the Wollaston Fund to an outstanding young micropaleontologist, Bridget Wade of Leeds University. She's already the holder of awards from the Micropaleontological and Paleontological Associations and a prestigious National Science Foundation Career Award. Bridget Wade has an outstanding record in research and teaching on both sides of the Atlantic. After graduating from Leeds in 1996, she took the UCL MSc in micropaleontology before going on to a PhD in Edinburgh on Eocene climate, studying stable isotopes in marine plankton. After a NERC fellowship at Cardiff and Edinburgh, she moved to America, first to Rutgers and then as assistant professor to Texas A&M. Bridget returned to the UK in 2010 as a NERC Advanced Research Fellow at Leeds, but remains an adjunct professor at Texas. She's currently supervising research students both here and in the USA, and has served on ODP cruises as well as the Tanzania drilling project. Bridget Wade, you're a highly talented scientist of great potential, in recognition of which we are delighted to award you the Society's Wollaston Fund. The R.H. Worth Prize celebrates the practice and encouragement of geological science by and among amateurs. And this year we're pleased to award it to one of this country's foremost amateur geologists, David Ward. David Ward, a vet by training and profession, has had a lifelong fascination with geology and paleontology and has made many important contributions over 35 years. He's now an internationally recognized expert in the field of Mesozoic and Cenozoic shark and ray teeth. He's travelled all over the world in search of fossiliferous deposits, from the former Soviet Union to the Sahara, often under dangerous and trying conditions. His extensive knowledge of Cenozoic stratigraphy has led to his involvement in projects ranging through sedimentology, magnetostratigraphy, and stable isotopes. He's also led the way with the development of instruments. An early achievement was the development of a mechanical sieving machine able to process large amounts of clay and silt for microvertebrate remains, leading to the discovery by him and others of many previously overlooked fossils, including the elusive Mesozoic mammals. He's published alone and in collaboration over 90 scholarly and beautifully illustrated papers on subjects ranging from taxonomy to biostratigraphy and paleoenvironmental studies. His careful biostratigraphic collection of shark teeth has led to the publication in our own journal of research which employed the stable oxygen isotopes in their apatite to reconstruct changes in salinity in the early Paleogene North Sea basin, giving important new insights to the many of us who study these fascinating and valuable rocks. It's an intriguing paper, I commend it to you. David's amazing collection of fossil Slakean teeth, housed in his home, attracts experts from all over the world, whom he welcomes and entertains in fine style, visits that are testament to the significant contribution he's made to international science. David Ward, please accept with our admiration and respect the R.H. Worth Prize of the Geological Society of London. The Sue Tyler Friedman Medal, awarded for excellence in research into the history of geology, was endowed by a foundation established by one of this society's senior fellows, the distinguished carbonate sedimentologist and historian of science, Professor Gerald Friedman, who sadly died late last year. And we'll take the occasion of this award to remember and salute a great benefactor of the society and a prodigious publisher of important papers in sedimentology. The award, named for Gerald's wife, goes this year to a geologist who has straddled many worlds in her career, Dr. Cherry Lewis. With a childhood interest in fossils, Cherry came to study geology as a mature student, obtaining academic qualifications in geochemistry, which led to a career in oil exploration. Until her recent retirement, she worked at the University of Bristol as an editor and media relations manager, promoting that institution's scientific research to a wider public. Cherry's interests, however, have long lain in the history of our science. An active member of the History of Geology group, HOG, she served as chair from 2004 to that crucial anniversary year of 2007, when she convened a conference on the Society's history with its memorable dinner in costume dress and co-edited the subsequent special publication. Cherry is well known as the biographer of Arthur Holmes and for her book about his life and work, The Dating Game. Great title. She's currently working on a biography of one of this society's founders, James Parkinson, best known today for giving his name to the neurological disease he first described. Cherry Lewis, you've been pivotal in developing the history of geology as a discipline within this society. Your personal drive and energy have been major factors in making HOG one of this society's most active and exciting specialist groups. Please accept with our respect and gratitude the Sue Tyler Friedman Medal of the Geological Society.
Well, thank you so much. I cannot say how delighted I am to be recognised for doing something that I enjoy so much. But I wouldn't be here today if it hadn't been for Bristol University and the Open University, where I took my degrees, taking me in as a mature student. To them, my undying thanks. Never in a million years did I imagine that I would one day be standing on this podium, let alone sharing it with my PhD supervisor, Chris Hawksworth, this year's Wollaston medalist. Well, I joined HOG about 15 years ago when it had been in existence for just a couple of years, and our membership was then very small. As John Fuller, one of the founders of HOG, who also sadly died this year, recalled for our oral history project, at the time, the Geological Society, as the world's premier society, seemed to be only distantly attached to its history. But over the years, this attitude has changed markedly, and it's now wonderful to see even die-hard geologists becoming interested in history. A few weeks ago, for example, I was at a meeting where, to my absolute amazement, there was John Dewey and Rob Butler, both giving historical papers. And even Chris emails me on occasion seeking bits of historical information. The history of geology as a discipline seems to have come of age, and I'm delighted to have played a part in that. Today, the Society's publications on geohistory are some of its best sellers, and you may have noticed that hardly a month goes by without there being an article on geohistory in Geoscientist. Ours might be a young science, but its history is full of vitality. It's the story of geologists and how they think, how their ideas have evolved, and how we come to be where we are now in the understanding of our science. It's an astonishing story that all of us in this room are part of, and it's a history we should all be very proud of. Thank you.
And in that connection, Cherry, I might add that the thanks to an initiative of my Cambridge colleague Dan Mackenzie, as you know, the full archive of the early papers on the development of plate tectonics. We come now to the Bigsby Medal, which this year goes to a key international figure in the development of luminescence dating and its application to the geological, geomorphological and archaeological sites. Professor Jeff Duller of Aberystwyth University. Jeff Duller's work has been instrumental in helping us to understand quaternary climate change and the rates of operation of a number of geomorphological processes. His research has covered four main themes: the design and development of luminescence equipment, characterizing the luminescent properties of minerals, developing analytical procedures for measuring luminescence, and writing research software for collecting, processing, and analyzing the data retrieved. His key technical achievements have included developing single aliquot methods of equivalent dose determination, developing the first widely available system for making optically stimulated luminescence, OSL measurements, of quartz, as well as the first widely available method for making OSL measurements on single sand-sized grains. I think one has to have struggled with the early equipment to fully appreciate the advances these developments represent. I used to share an office with an early luminoscope in it, with a machine that had to be coaxed into life that was industrial-sized plant and very, very noisy and smelly. Among his many notable research successes, we should cite dating the earliest evidence for human symbolic representation in the petroglyphs of Blombos Cave, South Africa, helping to rethink our understanding of how and at what rate linear dunes migrate, and being the first to apply single-grain luminescence methods to determine the timing of deglaciation in the southern Andes. He's also involved in assessing the feasibility of using luminescence to provide some chronological control of geomorphological activity on the surface of Mars. Geoffrey Duller, for your combined activity in developing the usefulness of this research tool and applying it to hitherto intractable research problems, many of fundamental importance to our understanding of climate change and human cultural evolution, please accept the Bigsby Medal of the Geological Society of London.
Mr. President, ladies and gentlemen, it's a great honour to be awarded the Bigsby Medal by such a prestigious body as the Geological Society. At school, I found it very difficult to choose between geography, geosciences, astronomy, engineering and physics. I've therefore been extremely lucky to have worked in a field of geochronology, and more specifically luminescence dating of quaternary sediments, where I've been able to combine my interests in all of those subjects. My research has really been a solitary activity, and much of the inspiration and the enjoyment has come from the people with whom I've worked. The person who I have to thank the most is Anne Wintle, who was my PhD supervisor, and later a colleague in Aberystwyth. Whilst an undergraduate in Oxford, Anne gave a seminar about the new geochronological method of luminescence, and it was at that point that my imagination was captured. Later, as a supervisor, Anne was critical, but always constructive, inspiring, generous, an extraordinarily good scientist, and always extremely good-humoured, a role model that I still aspire to. Anne introduced me to Lars Budde Jensen, with whom I developed a number of pieces of luminescence equipment. Without his support and that of the Radiation Dosimetry Research Group at Risø National Laboratory in Denmark, few of the achievements that I've made would have been possible. I've also been lucky to have worked with many colleagues from all around the world and to have had a number of extremely talented PhD students over the years. It is the combination of the science and the people that makes research so enjoyable. Finally, without the support and love of my wife and my two children, none of this would have been possible. I'd like to thank them and to thank the Geological Society for the great honour of conferring upon me the Bigsby Medal. Thank you very much.
The first of the Koch medals to be awarded today goes to a consummate field geologist whose research, spanning 3 decades, takes us back to what may be termed the intellectual heartland of much of this society's history, the geological evolution of the Scottish Highlands. Rob Strachan's work forms a keystone in constructing a deeper understanding of the age and deposition of Neoproterozoic rocks and the tectonothermal processes associated with the Caledonian origin and the development of the Iapetus and Rheic oceans. Clearly set out in a sustained series of publications, Rob's research has focused on unravelling the complex structural, sedimentological, metamorphic and geochronological history of deformed successions in this ancient mountain system and its associated sedimentary basins. It's been time-consuming, painstaking work, requiring the synthesis of observations spanning the true geological scale from microscopic to global. His many insights include documenting a major tectonic event during the Neoproterozoic evolution of the North Atlantic region, the enigmatic Neudatian orogeny, developing a structural model of the Great Glen Fault as an ancient Iapetan transform fault, and using chemostratigraphy to link the rocks of the highlands with correlative successions worldwide. The intellectual agility and sustained curiosity that informs his work has enabled him to combine leading-edge laboratory techniques with detailed methodical fieldwork of the sort that this society's founders would have recognised and approved most heartily. Rob, who began his research career in Kiel working on the Moyne Rocks of West Inverness, is now head of school at the School of Earth and Environmental Sciences at Portsmouth University. He's a truly collaborative scientist who freely shares his knowledge and ideas with collaborators and many research students. His work for the Society, including 8 years as subject editor and 6 as chief editor of JDS, in which role he was famously both firm and fair, reveals a level of commitment to collegiality that stands as an example to us all. Rob Strachan, please accept with our thanks and admiration the Koch Medal of the Geological Society of London.
Ladies and gentlemen, Mr. President, first of all, I must thank the Society very much indeed for bestowing such an unexpected honour, and indeed I feel very humble when I look back over the names of previous recipients of Koch medals. As is customary, there are many people to acknowledge over the years, starting with my parents, who greatly encouraged my academic studies. My father was a school teacher and insisted that I drew field sketches of folds in the Aberystwyth grits when I was age 7. Thankfully, a clutch of possibly poorly chosen arts A-levels did not prevent me from being accepted onto the BSc Geology course in Aberystwyth. Influential figures there included Bill Fitches, Dennis Bates, Alex Maltman and Max Dobson, who sent me off to do my undergraduate mapping to the Ross of Mull after, I have to say, a rather indifferent first couple of years on my degree course on my part. This seemed to be a huge adventure at the time and changed everything. Even after 6 weeks camping in a cow field in a small tent that absorbed Scottish rain like blotting paper, I knew that this was what I wanted to do. So thankfully I applied myself a bit more rigorously in my final year to my studies, won a NERC studentship to go to Kiel to study Moyne geology with John Winchester and Gilbert Kelling, and I also benefited a great deal from the support of Graham Park and Bob Roach. I was lucky, arguably, in being one of the last generation of PhD students who were easily able to go straight into a lectureship without postdoctoral research, and I thank Mike Brown, a previous Koch medalist, for appointing me to my first lectureship at Oxford Polytechnic and encouraging me to broaden my research horizons. And more latterly, I owe particular thanks to David Hughes, who facilitated my move to Portsmouth and a broader-based department with applied geoscientists and environmental scientists. Over the years, I have to acknowledge that I've been greatly inspired by my teaching. I've learnt a great deal from a succession of excellent research students and gained hugely from multidisciplinary collaborations with valued colleagues and friends too numerous to mention around the world. However, I especially acknowledge Nigel Woodcock, co-editor and co-author of our undergraduate textbook. Last and certainly not least, I thank my wife Wendy and my children for their continued support for a husband and father who has often been absent and probably not very attentive. Thank you very much.
The second of the Society's 2 Coke medals is awarded to a paleontologist who, in addition to the major contributions to our understanding of the lower Paleozoic as a whole, has done a great deal to help solve one of the longest abiding mysteries of the fossil record, the nature of the conodont animal and the part played by conodonts in the early evolution of vertebrates. Many of us will remember from student days those enigmatic tooth-like objects that, despite their biostratigraphic utility, were a complete biological mystery. Now conodont affinities in paleobiology are well understood, and the diversity of uses to which they are put has multiplied accordingly. This chapter of the story begins with the long-awaited discovery of conodont soft tissues in the early 1980s by Ewan Clarkson, Cope medalist in 2010. Dick joined Ewan, Derek Briggs and Paul Smith in describing and interpreting conodont anatomy. This finding confirmed the vertebrate affinities of conodonts and engendered a revolution in phylogeny, overturning almost every aspect of a textbook story that has stood more or less intact since the days of Charles Darwin. Dick took the opportunity to pioneer conodonts' use as geochemical proxies for Paleozoic oceans, especially in the Silurian. Working with Lennart Jepsen, this was controversial science involving major cyclical shifts in climate during what had been thought of as a period of relative stability, a view subsequently supported by isotopic work with Axel Munecker and others. Exceptionally preserved conodont soft tissues led Dick to an abiding interest in Lagerstätten, taking him from Grantanon the Firth of Forth, where conodont animal soft parts first emerged from obscurity, having been long trodden over by those of us urging sedimentology on generations of Edinburgh students, heedless of the other treasures beneath our feet, to the somewhat warmer surroundings provided by the Soom Shale in South Africa. This rare Ordovician Lagerstätte has provided unique insights into the high latitude ecosystems of the time and informed the study of a host of taxonomic groups, as well as having broader implications for sedimentology, taphonomy, and Earth system science. Dick, few paleontologists of your generation have set the agenda in so many different areas. To have led the way towards a new understanding of conodonts and vertebrate evolution might have been enough in itself. This achievement is set alongside much other significant work and makes you a most worthy recipient of the Coke Medal of the Geological Society of London.
Fellows, ladies and gentlemen, I'm extremely honoured to be awarded a Coke Medal. Although, as the President has said, conodonts have formed a constant core to my research interests, curiosity and chance have led me in many other directions, including biostratigraphy, paleoclimatology, and related dilettante dabblings with acritarchs and other fossils. I've also greatly enjoyed working on the paleobiology and taphonomy of Paleozoic Lagerstätten, especially the Lower Cambrian Xinjiang biota of China and the Upper Ordovician Soon Shale of South Africa. In these endeavours, I've had the good fortune in the calibre and character of my many collaborators. Ronald Austin introduced me to conodonts. Ewan Clarkson and Derek Briggs generously invited me into the Granson Conodont project, and Barry Rickards and Hannes Theron led me into the Soon Shale. My involvement in work on the Xinjiang biota has developed jointly with David and Derek Civita and with the discoverer of those exceptionally preserved fossils, Ho Shangguang. I've also been extremely lucky throughout my career with my research students and postdocs. They have all been good, and several of them have been outstanding, themselves rising to prestigious academic positions. They have been a constant source of stimulation and inspiration, and have ensured that my research drive has not slackened. If I have achieved anything, then much of that achievement is because giants have stood on my shoulders. So to conclude with my sincere thanks to everybody, to all those who have joined me at various stages along the pathway through my career, to my family who have supported me throughout, to those who nominated me for the Coke Medal, and to the Geological Society of London for making the award. Thank you.
We come now to the three of our senior medals that, let me remind you, have equal standing, William Smith, the Lyell and the Murchison. And the medal named for William Smith celebrates outstanding achievement in the field of applied geology. And this year we're delighted to present it to an outstanding practitioner, not this year to one of Smith's fellow engineering geologists, but to an internationally influential figure in natural hazards and risk assessment, Willie Aspinall. Willie Aspinall's work has been applied to a wide range of problems for a wide range of clients, mostly, as in the case of William Smith himself, as a private consultant running his own business, Aspinall and Associates, although recently he's also been appointed part-time professor at the University of Bristol. Willie Aspinall has made pioneering contributions in applying quantitative risk assessment and management techniques to volcanic hazards, especially during the eruption of the Soufriere Hills volcano, Montserrat. This work has had worldwide impact on applied volcanology, in which he is now seen as a leading expert. His work followed by institutes in such diverse volcanic provinces as New Zealand, Italy, and the USA. His work on Montserrat as Joint Chief Scientist in the early stages of the eruption developed into a pivotal role as he provided the quantitative risk analysis that has underpinned the 6 monthly hazard and risk assessments supplied to UK and Montserrat governments. In this work, he's pioneered probabilistic and expert elicitation methods in crisis management, which, together with his understanding of both earth science and statistics, has been central in enabling effective management of this long-term hazard. Many of Willie's contributions have ranged beyond volcanoes, taking in such pressing topics as seismic hazard and nuclear power, the safety of UK dams, bioterrorism, disease threats, the implications of climate change for nuclear waste disposal, and aviation safety during the recent volcanic ash crisis. Willie Aspinall, for your pioneering and wide-ranging contributions applying the earth sciences to the benefit of all, it is my great pleasure to award you today the William Smith Medal of the Geological Society of London.
Mr. President, ladies and gentlemen, thank you for your kind words. I also extend my thanks to the Council and the Fellows who nominated me for this award. I have done very little of academic distinction or scientific merit to warrant my name being added to the list of those famous people who won this medal in the past. So I must conclude that it's been several years of sharing beers in the field and sundowners in the tropics, which have deluded some of my more tolerant colleagues into believing that I've contributed more to geology than I really have. Serendipity has played a huge role in my career. Good luck found me a postdoctoral position at the Seismic Research Unit at the University of the West Indies in Trinidad, and almost immediately rewarded me with a spirited wife and an eruption of the soufriere of St. Vincent volcano, engendering a lifelong absorption with unpredictability and volcanoes. Volcanic crises and eruptions enable me to get to know many of the leading lights of volcanology, and I owe a major debt of gratitude to all for their unique camaraderie and for the generosity with which they shared their knowledge and understanding with a non-geologist. My background is in physics. Returning to the UK in the early 1980s, chance again and some seismological understanding drew me into work on earthquake hazards for the nuclear industry, which the President just mentioned, and through the Seismic Hazard Working Party into close professional contact and friendship with Brian Skip, with Ian Higginbottom, David Mallard, Robert Muirwood, Gordon Wu, several other fellows of this society, and including our incoming President, David Shilston. Here again, my own scientific shortcomings have been masked from wider view by the charitable scientific support of these erudite and intellectually expansive individuals, and I thank them as well. Many of the precepts that we developed for the nuclear industry on probabilistic hazard and risk assessment proved invaluable when in 1995 the Soufriere Hills volcano in Montserrat started erupting. Over the intervening 17 years, and I should mention that I went there in the first week of the crisis and apparently told the then governor of the island that it would all be over by Christmas. So 17 years later, I've had the good fortune to play a small role in the scientific advisory committee that advises the British government and the Montserrat government under the enlightened leadership of two chairmen, our former president Stephen Sparks and Geoffrey Wodge. Conducting elicitations of expert judgment as the eruption evolved and as the cast of opinionated geologists grew, seemingly exponentially, I have benefited from their supportive contributions and their trenchant banter and geological ribbing, both in the Scientific Advisory Committee and at the Montserrat Volcano Observatory. Adopting a formalised approach to expert elicitation in such a situation was inspired by the groundbreaking work of a mathematician, Professor Roger Cook, and he has provided me with continual encouragement and support, and I'm grateful to him for that. My final words of gratitude are for my wife Felice, our two daughters, and latterly our hard-to-impress grandchildren. They don't think much of Grandad on telly, they'd rather see Oggy and the cockroaches. They've had to put up with the inevitable absences and a certain distractedness when I am at home, so I share this award with them. Thank you.
I was warned there might be a little bit of rowdiness when so many supporters were coming with you, but everybody was pretty restrained. Grandfather obviously rules somewhat. Sir Roderick Impey Murchison was, among his countrymen, one of the 19th century's most widely travelled earth scientists. So it's perhaps appropriate that we award this year's Murchison Medal to another widely travelled scientist from the United States. Frank Spear is a metamorphic petrologist who's pioneered the development of the quantitative thermobarometry and pressure temperature time path analysis that underpins modern tectonic studies of mountain belts. Throughout his career, first as a professor at MIT and then at his present school, the Rensselaer Polytechnic Institute, he's undertaken rigorous investigations of the phase equilibria of metamorphic rocks. He led the way in understanding the significance of trace element zonation in metamorphic minerals and of accessory mineral stability, both factors now understood to be crucially important in interpreting metamorphic ages and rates. The goal of this work has been to construct pressure, temperature, time histories that can inform the tectonic evolution of a terrain. He and his many students and collaborators have applied these techniques in the Alps, New England, southern Chile, the Mojave Desert, British Columbia, the Adirondacks of New York, the Norwegian Caledonides, and the blue schist belt of the Greek Cyclades, an itinerary of which even Sir Roderick would perhaps have looked askance. Present-day teaching fellows at Harvard University, leading undergraduates through Vermont, New Hampshire, and upstate New York, have Frank's work to guide them. I wish that had been true for us in the 1960s. Frank is credited with writing a trilogy of landmark works that have been described as the three most highly cited contributions in modern metamorphic petrology. These are his 1978 experimental study with John Ferry on the partitioning of iron and magnesium between biotite and garnet, his 1982 study with Kip Hodges of the schists at Mount Musilaki, New Hampshire, and his magnum opus, a monograph on metamorphic phase equilibria and pressure, temperature, time paths, which has become the standard work of reference for those working in this broad field. With this work, published by the Mineralogical Society of America, together with a number of associated computer programs, Frank has presented his contemporaries with the essential toolkit of their profession. Frank Spear, you are indeed a worthy recipient of the Murchison Medal of the Geological Society, which it is my great pleasure to present to you now.
President, members of the Geological Society, ladies and gentlemen, to stand here before you today and receive the Murchison Medal is without question the greatest honor of my scientific career. The honor is even greater because I feel a kindred spirit with the Geological Society. After all, it was George Barrow, another recipient of the Murchison Medal, who discovered the metamorphic field gradient and essentially launched the discipline of metamorphic petrology. And it was the visionary work of yet another recipient of the Murchison Medal, Phil England, that served to shift the paradigm of metamorphic petrology from a static view of crustal geotherms to the dynamic interaction of collisional tectonics and thermal perturbations. This extraordinary insight launched entire new directions of study into deciphering of metamorphic PT paths and really became a driving force in my own scientific path for the next 30 years. As was Sir Roderick Murchison, I have been blessed to be able to do fieldwork in some amazing places in my life. But one thing that I have learned is that no matter how much I think I know about the geology of an area, it's always possible to discover something new, especially when one has an arsenal of new tools, new methods, and it doesn't hurt to have a couple of $1 million mass spectrometers and electron probes. I've also been blessed with superb mentors, outstanding students, and marvelous colleagues. Mel Kuntz introduced me to the way phase equilibria could unravel the secrets of rocks. Doug Rumble taught me the intricacies of thermodynamics and how to apply these to metamorphic assemblages. And Gary Ernst kept reminding me that the reason we study metamorphic rocks in the first place is to unravel the tectonic history of the planet. And my own students and colleagues have always been there to keep some of my more outlandish ideas in check. And when I peruse the list of recipients of the Murchison Medal, I'm all the more awed and humbled by that you consider me worthy of this recognition. I'm also deeply pleased and grateful, and I thank you all very much indeed.
The medal named for one of the 19th century's most influential geologists, Sir Charles Lyell, goes this year to a geochemist whose work has focused not on rocks, but on ice. The study of ice as a guide to past climate is becoming increasingly influential in our urgent struggle to understand what effect we may be having on our planet. Eric Wolf began his career working on pollutants in polar snow, measuring lead in these hitherto supposedly pristine environments. This work led him to advance our understanding of the rates and mechanisms of exchange between the atmosphere and the Earth's ice caps. He began to publish on the climate implications of acidity measured from electrical logs of Greenland ice, and as a result became involved in experiments showing the importance to the physics of ice of impurities located at boundaries between ice grains. Eric then became interested in ice core's paleoclimate record, looking first at fast changes in dust concentration in Greenland ice over the last 100,000 years. He was appointed chief scientist for the European Project for Ice Coring in Antarctica, EPICA, and chair of EPICA's science group. This led to a landmark Nature paper in 2004 on 8 glacial cycles from an Antarctic ice core, and to several papers considering the controls on the glacial interglacial cycles and rapid climate changes that characterize the Quaternary record. These and other works have marked him as a world expert on ice chemistry and a leader of the ice coring community. He's currently co-chair of the International Partnership in Ice Core Sciences, which aims to drill ice 1 million years old in the Antarctic. Eric serves as science leader of the British Antarctic Survey Programme, Chemistry and Past Climate, and has shouldered a host of other responsibilities in international bodies and initiatives. Among his many scientific affiliations, I should mention that he's not only a chartered member of the Royal Society of Chemistry, but also a Fellow of the Royal Society. The ultimate accolade of chartered geologists will surely not elude him for long. He has connections to many other prestigious organizations and is a busy editor for scientific journals specializing in quaternary science. Eric Wolf, your contribution to the paleogeochemistry of the Earth's ice caps and its implications for climate has been exemplary. You've been prepared to explain to fractious audiences the broader implications of your outstanding achievements in observational science. It is my great pleasure to acknowledge this work by awarding you the Lyell Medal of the Geological Society of London.
President, fellows, ladies and gentlemen, I'm hugely honoured, as all the medalists, to receive this prestigious medal. In my career, I've been called many things. Among the polite ones are chemist, as you alluded, glaciologist and paleoclimatologist, but I suspect that my geological friends, some of whom are in the audience, are most surprised to find that I'm now among their ranks, and I greatly appreciate your broad-mindedness in awarding this medal for work on the very softest of rocks. I actually take this award as being a recognition not just of my work, but of the entire field of ice core science. Ice turns out to be a rather special sediment, holding a unique archive of the atmosphere. The pioneers who collected the first deep ice cores in Greenland and Antarctica cannot have realised how their work would eventually lead to a revolution in quaternary science. It's been a privilege for me to play a role in this work and to help provide records on which our understanding of past, present and future climate change depend. Now, I realise that my ice cores span only a minute slice of the time period celebrated in this building, but still it excites me as well to see a slice of ice that fell as snow 500,000 years ago, and I hope this excitement inspires others to unravel more of the processes that shape the Earth and its climate. I find myself in this position through a series of lucky breaks and generous colleagues. At the British Antarctic Survey, David Peel, Julian Parent and Chris Doak all allowed me to steer far away from the work I was actually employed for, broadening my scientific mind. And among my many other colleagues at BAS, Robert Mulvaney has been a friend and essential collaborator for over 25 years. A brief stay with Claire Patterson at Caltech showed me how important it is to do geochemistry properly, while the inspiration of spending time in the field with colleagues such as Sigfrid Jonsson helped me to find the questions I really want to answer. Much of my most influential work has come from the combined efforts of the scientists from 10 nations in the EPICA project. You'll be glad to hear I'm not going to name them all. And finally, this is an opportunity to thank my wife, Teresa, for her unquestioning support and love through many field seasons, and perhaps just as important, equally fraught deadlines for conferences and papers. Thank you very much.
Finally, we come to the Wollaston Medal, the Society's premier medal and highest accolade, first awarded to William Smith in 1831. Professor Chris Hawkesworth, this year's laureate, is internationally recognized as one of his generation's most outstanding geochemists, whose work has run the gamut of isotopic systems, including neodymium, lead, uranium, thorium, uranium series, and most recently, hafnium and oxygen in zircons. Chris's scientific publications, numbering about 300, cover key fields, including mantle melting, element flux at subduction zones, heterogeneities within the mantle, of which I'm particularly fond, and the differentiation and evolution of the crust. His contributions include many fundamental advances, and his impact, evinced by a stellar ISA citation index of 77, has extended over the entire length of his 40-year research career. His influence continues today, with 2 recent papers in Nature and Science rapidly accumulating the characteristic Hawkesworth totals of citation. What drives this success is Chris's outstanding ability to take and solve tractable problems of high general impact. His enthusiasm attracts and inspires young researchers to his side, as we've heard this afternoon. And his lasting international influence on isotope geochemistry relies in no small measure upon the pivotal role he's played as team leader and mentor for 2 of the foremost earth science isotope groups in this country, namely those of the Open University and more recently of Bristol University. Nor has Chris neglected his role within the wider scientific community, serving on a wide range of national and international scientific committees. He served this society as Science Secretary, as well as the European Association for Geochemistry as President, the Geochemical Society as International Secretary, and has also served as a member of the International Ocean Drilling Programme's Mission Review Panel. There have been many others. He was elected to the Fellowship of the Royal Society in 2002, of the Royal Society of Edinburgh in 2012, and he's currently Deputy Principal of the University of St Andrews. Chris, your work has been a major influence, not only on your own field, but in the wider understanding of the Earth system over 4 decades. You, or many students and co-workers, owe you an enormous debt, as do all those organisations fortunate enough to have benefited from your involvement. It therefore gives me the greatest pleasure to acknowledge this outstanding achievement by awarding you the Wollaston Medal of the Geological Society of London.
Thank you, Mr. President. It's probably a place to come if you really want to feel old this afternoon. But thank you for your kind words, ladies and gentlemen. Good afternoon. And thank you. I'm really humbled and delighted to receive this most prestigious medal. I mean, the list of previous winners included many people I never dreamed I might be associated with, and I'm deeply honored to be linked to them in this way. I'm delighted, too, to feel welcome back into the geological community with rocks and the processes that shape them at the heart of what we do. For me, it's been a wonderful time to be an earth scientist. I seem to remember some confusion in the lectures I sat through as an undergraduate about whether plate tectonics was really here to stay. That may date me too. But it clearly provided the framework for the emphasis on studying natural processes wherever they are best recorded. The subject was revolutionized by an increasing ability to determine rates at which natural processes took place from the rock record. In part, this was linked to spectacular developments in mass spectrometry. And we've gone from home-built mass spectrometers for the analysis of lead and for strontium isotopes to plasma source machines capable of analyzing isotope ratios for most elements on the periodic table. Laser and ion probes have encouraged a shift from the analysis of whole rocks, those powders of all the minerals present that just may or may not be related to one another, to tiny spots in well-characterized minerals. The result is a treasure trove of opportunity, given what can now be achieved analytically. Isotope geochemistry is perhaps more of a team activity than most, and the person who stands here does so because of the endeavors of many colleagues, students, and postdocs who have been part of highly successful groups, as we've heard, at the Open and Bristol universities. But none of this would have happened if Ron Oxborough had not taken a chance on this Trinity graduate who had spent much more time on the rugby field and looking at outcrops, and encouraged him to join his group working in the Eastern Alps. So I owe Ron and my fellow DPhil students, in particular Mike Bickle and Philip England, a huge debt for starting me on this road. Keith and Irons tried hard to teach me the rudimentary aspects of mass spectrometry and geochemistry, and Keith Cox was always there puffing on his pipe and ensuring we paid attention to what the rocks and minerals might tell us. Sadly, there's not space to identify all the people who have helped and supported me along the way, but the success of the Bristol Isotope Group is in very large part down to the imagination and the inclusiveness of Tim Elliott and Derek Vance. And St Andrews, it's been richly rewarding to see the re-emergence of geology under the leadership of Peter Kaywood, who's also here today. And throughout it all, there's been the love and support of my wife Celia, as together we've shared the delights and richness of university life. I thank them all for everything we've done together, and I thank you, the Geological Society, for the great honour of the Wilson Medal. Thank you very much indeed.